Jetpack Compose is a modern toolkit for building native Android user interfaces using Kotlin. It represents a fundamental shift in how we create Android applications, moving away from traditional XML layouts to a purely code-based, declarative approach. This makes UI development faster, more intuitive, and significantly easier to maintain. Jetpack Compose is Google's latest framework for building native Android user interfaces. It introduces a declarative approach, which means you describe what your UI should look like rather than writing step-by-step instructions on how to build it. This results in less code and more powerful capabilities. The framework is built entirely with Kotlin, leveraging its modern language features to create intuitive APIs that make UI development a breeze. Let's compare the traditional approach with Compose. Traditional Android development uses XML layout files, requires imperative updates where you manually change UI elements, relies on find view by ID calls to access views, and involves substantial boilerplate code. In contrast, Compose uses pure Kotlin code, provides declarative updates where the UI automatically reflects data changes, offers direct references to components without searching for them, and requires minimal code to achieve the same results. Here's your first composable function. The @composable annotation marks this function as one that emits user interface elements. We define a function called greeting that takes a string parameter called name. Inside, we simply call the text composable, passing it a string that says hello, followed by the name variable. That's it. This single function creates a text component that displays a greeting message. Notice how concise and readable this is compared to traditional XML and Java code. There are three key concepts you need to understand. First, the @composable annotation marks functions that emit UI elements. Any function that creates or displays user interface components must have this annotation. Second, recomposition is the process where your UI automatically updates whenever the underlying data changes. You don't need to manually update views. Third, state management allows you to track and respond to data changes efficiently. Compose provides powerful tools to manage state in a way that triggers recomposition only when necessary. Column is a composable that arranges its children vertically. In this example, we create a profile screen function that uses a column to stack three text components. The first displays John Doe, the second shows Android developer, and the third displays Kotlin enthusiast. All three text elements are automatically arranged one below the other in a vertical layout. This is much simpler than defining linear layout with vertical orientation in XML. Row is the horizontal counterpart to column. It arranges its children side by side horizontally. In this action bar example, we create a row containing three text components: like, share, and comment. These elements are automatically placed next to each other from left to right. Row and column are the fundamental building blocks for creating layouts in Compose, and they can be nested to create complex user interfaces. Managing state is crucial for interactive UIs. The remember function tells Compose to store a value across recompositions. In this counter example, we declare a variable called count using the remember function with mutable state of initialized to 0. The by keyword enables property delegation for cleaner syntax. We then create a button that increments the count when clicked and displays the current count value in its text. When count changes, Compose automatically recomposes just the button to show the updated value. This is the power of declarative UI and automatic recomposition. There are compelling reasons to choose Compose for your Android projects. First, it requires significantly less boilerplate code compared to XML-based layouts, which means you can build features faster. Second, Compose offers better maintainability because your UI code is easier to read, test, and modify when everything is in Kotlin. Third, you get full type safety. Since Compose is pure Kotlin code, the compiler catches errors at compile time rather than at runtime, preventing many common bugs. These benefits make Compose the future of Android UI development.
If you like this video, Hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.